In number 17, we're looking at a one-sided infinite limit. Now, why is this an infinite limit? Because when we substitute in 4 into the function, on top we get something non-zero, and in the denominator we get 16 minus 4, that's 12. 12 minus 12 is 0. So we get something non-zero over 0. So I call this a 1 over 0 limit. A 1 over 0 limit is either going to be infinity or minus infinity. Or I should say a one-sided 1 over 0 limit is going to tend to infinity or minus infinity. Alright, in order to determine if this is infinity or minus infinity, we have to do what we call plus-minus analysis on our function, which determines the sign of the function. We only need the sign of the function to the left of 4. Okay, so to do that we have to factor our denominator. Alright, so what we're doing is a plus-minus analysis. And what it involves is we have to put the zeros of the numerator and denominator on the number line. And look in between on the intervals, look on the intervals formed and see if the function is positive or negative in between the zeros of the numerator and denominator. It's only at the zeros of the numerator and denominator that the sign of a rational function can change. Okay, in other words, let's factor this. Okay, so this factors x squared minus x minus 12 factors into x minus 4, x plus 3. So this rational function can change sign when x is 0, that's the 0 of the numerator, when x is 4, the 0 of this factor, or when x is minus 3. In between, the sign stays the same. Alright, it's not hard to see why that's true if you just look at this function carefully. X is always negative to the left of 0 and positive to the right. X minus 4 is negative to the left of 4 and positive to the right of 4. And x plus 3 is negative to the left of minus 3 and positive to the right of minus 3. And so when you multiply these three factors together, the signs will change when the signs of each factor change. Alright, so on the number line, this is the plus-minus analysis. We put the zeros of the numerator and denominator in order. So we'll start with minus 3, open circle, because minus 3 is not in the domain. And then 0, that's coming from the numerator, that is in the domain. And then 4, open circle, 4 is not in the domain. Now we really only are interested in the interval to the left of 4. So this is the interval. We want to know the sign of this expression on this interval. And since it's always, the sign doesn't change in this interval, we can pick any value. I can pick 1, 2, 3, 0.1, 3.9. Okay, let's say we pick 1, anything in this interval, and substitute in here. Alright, now we don't have to get the exact value. We only want to know, is this expression positive or negative when x is equal to 1? So look at each factor separately. When x is equal to 1, the numerator is 1, or it's positive. 1 minus 4 is negative. 1 plus 3 is positive. So we have two positives and the negative. That makes the expression negative. And that tells us that this limit is minus infinity. Okay. Okay, here we have another one-sided limit of a rational function. Let's substitute 2 into the numerator. We get 2. Substitute into the denominator, and we have 4 minus 10, that's minus 6, plus 6, which is 0. So we have 2 over 0. So again, this is a 1 over 0 one-sided limit. So it's going to go either to infinity or minus infinity. Let's factor and do our, again, we're doing a plus minus analysis. So first start with factoring the denominator. So the denominator factors into x minus 2 times x minus 3. So on the number line, we'll put our zeros of numerator and denominator. So we're in order. So we're going to start with 0, the 0 of the numerator. Closed circle because 0 is in the domain. Then 2 and 3. 2 and 3 are not in the domain, so they get open circles. The interval that we're interested in is the interval to the right of 2, so that's right here. So we have to substitute in something between 2 and 3. So let's say we pick 2.5. And here we have something positive. When we sub 2.5, 2.5 minus 2 again is positive, and 2.5 minus 3 is negative. So we have 2 positives and a negative. So that means our expression is negative. And that means that the limit as x goes to 2 from the right of x over x squared minus 5x plus 6 is minus infinity. In number 19, we want to prove that x cubed minus 2x plus 5 has a 0, or that means is equal to 0, somewhere in the interval between minus 3 and 2. All right, so we want to try to use the intermediate value theorem. The intermediate value theorem can be applied to functions that are continuous on the interval that we're looking at. So first, we have to say that f of x equal to x cubed minus 2x plus 5 is a polynomial, and polynomials are continuous on the entire x-axis. So it's a polynomial, which implies it's continuous. All right, now what we're going to do is we're going to look at our function evaluated at minus 3 and then evaluated at 2. So let's say f of minus 3. So we want to see the value of the function at the starting point in our interval. Okay, so substitute in minus 3. So here we have minus 27 plus 6 plus 5. So this is minus 21 plus 5. Okay, so that minus 16 is the value that the function starts at the beginning of the interval. Now let's see where the function ends up. Let's substitute in 2. So here we have 2 cubed, that's 8, minus 4, plus 5. Okay, so that's 4 plus 5, that's 9. All right, so the function starts off at minus 16. It ends at 9. All right, now 0 is in between these two values. And the function's continuous, so that means that there exists c in minus 3, 2 such that f of c is equal to 0. And we're not asked to find what c is equal to, all right, just that it exists. In number 20, we have a quadratic function, x squared, and we want to show that f of c is equal to 2 in the interval 2, 5. And this time we do want to find the value of c this time. All right, so first of all, we have to start by saying that f of x is a polynomial, so it's continuous. Okay, we're looking at the interval 2, 5. So let's look at where f starts out at 2. What's the value of f? So that would be 4. Substituting in, we have 4. Minus 4 times 2 is 8. Plus 5. That's minus 4 plus 5. That's 1. All right, now where does it end up? Let's substitute in 5. 5 squared, that's 25. 4 times 5, that's 20. Plus 5, so here we have 5 plus 5, so that's 10. So it starts off at 1, and it ends up at 10. Okay, so it does go through 2. 2 is in between 1 and 10. So 2 is between these values. So that way we know that there exists c. In 2, 5, such that f of c is equal to 2. And now we want to find c. In this case, we want to find c. Since we have a quadratic, it's not going to be hard to find c. So all we have to do is set the quadratic equal to 2. Okay, so we have what we have to do is solve. We want to know for what x value is this equal to c. Okay, so this is what we have to solve. C is 2. All right, subtract 2 from both sides, and let's first see if we can factor this after we set it equal to 0. All right, and what do we have? We have x minus 3, x minus 1 equal to 0. So we have x equals 3 and x is equal to 1. And let's remember what our interval is here. Our interval is 2, 5. So 1's not in this interval, but 3 is. 3 is between 2 and 5. So that's our c value.